Friends, excuse me, we shall be continuing with discrete time signals and the properties. Today we shall be discussing about linear systems, linear time invariant system. In short, we call them LTI system. What is a linear system? In the discrete domain, we define a linear system as the one where if I give an input x1n and we get a corresponding output as y1n, if I have x2n as the input, y2n is the corresponding output, then for a combination of a1 x1n plus a2 x2n, these are scaled by factors a1 and a2, if I get an output a1 y1n plus a2 y2n, then it is a linear system. That is, we can apply superposition theorem. That is the acid test for any linear system. Sometimes you must have also studied in earlier classes. If you have a resistance R, you have a voltage V, there is a current I, then V by I is equal to R. This is a say heater coil of constant resistance, it is a linear system. If I measure the heat generated, then it will be V squared by R, it is a nonlinear system. So, the same resistance which is constant in magnitude can represent a linear system, can represent a nonlinear system also. It all depends on the input output pair that you are selecting. In a dynamic system, if you have a differential equation, d square x by dt squared plus 5x is equal to log of t, okay, I should write small, or 2 into d square x by dt squared whole squared plus 5 dx by dt is equal to 2t. 2 into d square x by dt squared plus 5t into dx by dt is equal to sin t, and 2 into d square x by dt squared plus 5 t square x is equal to sin square t. Now, in this, which one or which ones are linear system? First one, it is a linear system. Any question? This is a nonlinear function of time t, all right, but this is a forcing function. So, system's behavior is independent, the system's nature is independent of the forcing function. This one, it is a nonlinear function, because in dx by dt or d square x by dt square, x and its derivative are taken as the dependent variables, and it is appearing in a nonlinear form in the dependent variable. So, it is nonlinear. What about this? This is linear but time varying, all right, linear but time varying. What about this? This is also linear time varying. Now, we are trying to search for those functions which are linear and time invariant. So, only the first one is linear and time invariant system, because on the left hand side you have x, x dot, x double dot etc., without any coefficient involving the independent variable t. Okay. So, we will be taking up now such systems, that is linear time invariant system. Okay. Now, linear time invariant system is represented by its impulse response Hn. Okay. If I excite the system is described by its impulse response. All right. If I excite the system given input of xn, what will be the corresponding output yn? Hn is given is the impulse response of the system, maybe H0, H1, H2. Okay, we may give you the values H0, H1, H2. Then for any input sequence, what will be the output? Now, xn, I can write this as x0, x1, x2, x3 and so on. Suppose it is a finite sequence like this. This can be conceived as x0 occurring at t equal to 0, it is an impulse of magnitude x naught, okay, and then it disappears, plus another impulse of magnitude x1, but appearing after one delay, plus x2 delta n minus 2 plus x3 delta n minus 3, where basically x0 is x at 0, x1 is x at 1, x2 is it not? These are the values occurring at these points. So, what we are doing is, suppose you are having values like this x1, x2, x3, we are trying to represent this sequence as equal to x0 multiplied by delta n plus x1 delta n minus 1, that is of magnitude x1 and an impulse occurring at n is equal to 1, plus x2 delta n minus 2 and so on. So, basically this sequence can be conceived as impulses occurring at a different instance, impulses of different magnitudes. Now, what will be this is basically the sequence written in component forms. Now, if we apply superposition theorem, the impact of individual components can be summed up. We had already described a linear system as combination of a1 x1n plus a2 x2n is equal to a1 y1n plus a2 y2n. So, whatever this can be considered as a x1, x2, x3 and so on. So, whatever is the response due to this plus response due to this, response due to this, if all of them are added together, that will be the response. Okay. This is for a linear system. Now, for a time invariant system, if xn is the input and corresponding output is yn, then if the same input is given, instead of at t equal to 0, I give it after say an interval of 5 steps, 5 sampling time. So, x n minus 5 will give me an identical output y n minus 5, that is for a time invariant system. Its response, nature of the response will remain invariant, okay, invariant of time. So, if that is also applied, then what will be the response due to this of this system? For delta n it is h n. So, for x naught into delta n it will be x naught times h n. So, the response for the first one will be x naught into h n. Do you all agree? Then for the second component, excuse me, for the second component which is x 1 delta n minus 1, what will be the corresponding output? X 1 h n minus 1. By invariance principle, I have shifted the input by one step, output is also shifted by one step. X 2 delta n minus 2 will be giving me x 2 h n minus 2, all right. So, I am using the principle of time invariance, and now we are applying superposition theorem. So, superposition theorem says if I now have addition of these as the input, output will be addition of these. So, corresponding to the sum is nothing but x n, original x n, the output will be correspondingly x 0 h n plus x 1 h n minus 1 plus x 2 h n minus 2 and so on. One may write what is x 0, it is nothing but this h, I may write n minus 0, n can be written as n minus 0 plus x 1 is this one into h n minus 1 plus x 2 into h n minus 2 and so on. So, this can be written as a summation x k h n minus k summated over k equal to 0 to infinity if it is an infinite sequence, all right. So, this is known as convolution sum of the two sequences x n and h n. Let us see how this can be computed in a very effective manner. Suppose we have the sequence x n as 1 minus 1 2, okay, and then it is all 0, h n as 2 1 minus 1, all right. What will be y 0? And this is my y n. This corresponding to input, this is an arrow not equal to, corresponding to input x n, the output is this, which is y n. So, what is y n? Y n we have written as summation x k h n minus k. So, y0 should be n is equal to 0, it should be xk h 0 minus k. You keep on varying k, all right. Take k equal to 0, it will be x 0 h 0, okay, nothing else can be taken. So, that gives me 1 into 2, 2. What will be y 1 x k h 1 minus k, vary k. So, if I take k equal to 0, this will be x 0 h 1 plus x 1 h 0, only 2 terms, and that is x 0 h 1 plus x 1 h 0, 1 into 1 minus 1 into 2. So, that gives me minus 1, okay, and so on. Y 2 will be similarly, you have to make other combinations. Is that all right? Now, this can be made this computation for each step you have to make such expanded terms, you have to compute and you have to make such calculations. Can there be a shortcut? Let us see. Suppose we make a table, on this side we arrange h, h0, h1, h2, h3 and so on. This side we write x0, x1, x2, x3 and so on, okay, whatever be the length of the sequence. So, this is the response due to a delta function, delta n. If I excite it by an impulse of magnitude x naught, what will be the response? This whole thing gets multiplied by x naught. So, this will be x naught h naught, x naught h1, x naught h2, x naught h3 and so on. x1 we are applying after one sampling time, after one interval. So, the corresponding response, which will be x1 h0, x1 h1, x1 h2, x1 h3 and so on, will start after one interval, all right. So, it will start from this point x1 h0, x1 h1, x1 h2, x1 h3. Similarly, the impulse of magnitude x2 will start after two intervals. So, it will be x2 h0, x2 h1, x2 h2, x2 h3 and so on. Similarly, x3 will have its effect felt from this point onward, and x3 h3. Now, you apply superposition theorem. So, what is the response in the first interval at the first instance? It will be only x0 h0. So, this is y0. At the second interval, that is at n is equal to 1, the impact of the first one is still there and the new one has come. So, it will be this plus this. This will be y1. Similarly, 3 terms will be added here, that will be y2. So, x0 h2 plus x1 h1 plus x2 h0, this will be y2. you can write either this or in bracket, it is one and the same thing. Have you observed one thing? In any sequence, the sum of these terms will be same as this index, alright. So, while adding up, you know what are the terms to be taken for calculating the products and then final addition, okay. Suppose you have taken a 4-point sequence here and a 4-point sequence here, alright, then you see what will be the length of this, length of this 4, there are 2 trains of length say 4 compartments and 5 compartments, alright. When they meet, then only you start computing this value into this value, say, okay. This is H0, H1, H2, H3, H4 and so on, and this side is X0, X1. The sequences were like this, so you have reversed it, alright. In a time you have made a time reversal. So, this is X0, X1, X2, X3 and then you bring them together, alright. So, the first point it will be X0 into H0, next it is X0 H1 and X1 H0, and at the end when they are just touching each other, then only you will have an interaction, after that there is no effect, is it not. So, when do the tails of these two meet? So, how many steps are there? So, there are 4 steps on this and there are 5 steps on this. So, if you take from this point and this point, how many steps you have made? 8, 5 plus 4 minus 1, alright, 5 plus 4 minus 1. So, here you are having 4-point sequence, 4-point sequence, it is including 0 mind you. So, it will be 4 plus 4, 8 minus 1. So, the length of the sequence will be 7, is it alright? So, length of the sequence, if this is of length m, this is of length n, then the length of the output sequence will be m plus n minus 1. This is the length of yn, okay. Just some time back, in the last lecture we had discussed about even and odd functions. If a sequence is complex, a sequence may be complex. If you have a complex sequence, then we define another kind of symmetry. Conjugate symmetric sequences xn, if it is equal to x star minus n, then we call it conjugate symmetric, okay. And similarly, conjugate antisymmetric sequences we define as this, okay. Once again, any sequence, any complex sequence can be written as the sum of symmetric part, conjugate symmetric sequence, and conjugate antisymmetric sequence, all right. So, any complex sequence x n can be written as this. What will be these components? So, x n is equal to x symmetry n plus x, I just write anti n. What will be x minus n? X symmetric minus n plus x anti minus n. Okay. And what is x symmetric minus n? For a symmetric function, x minus n, it will be x star. So, this is nothing but x symmetric star n, is it not? And this one, it will be minus x anti star n, is it all right? So, from here what will be x star minus n? It will be x symmetric n minus x antisymmetric n. I have just again taken conjugate of that on both sides. So, that gives me this. Now, add this with this with this will get cancelled. Okay. Therefore, if we take x n plus x star minus n by 2, we will get the symmetry component, and similarly the conjugate antisymmetry component will be x star minus n by 2. Let us take an example. X n is given as 2, 1 plus j 2, 5 minus 4 plus j 2, 2 plus j 2 and j 4. Therefore, x minus n will be from the other side. If you take the sequence 2 plus j 2 minus 4 plus j 2, 5, 1 plus j 2 and 2. Okay. So, x star minus n will be complex conjugate of this sequence minus j 4, 2 minus j 2, minus 4 minus j 2, 5, 1 minus j 2 and 2. Agree? So, what will be the symmetry component? Symmetry component, half of x n and x star minus n divided by 2. So, this plus this by 2. Now, where should I, this plus this divided by 2, keeping the origin intact. So, this does not have any counterpart here. So, this divided by 2. So, minus j 2. Okay. Then 2 minus j 2 plus 2 divided by 2. So, 4 minus j 2 by 2. So, 2 minus j, correct me if I am wrong. Then this and this divided by 2. So, minus 4 plus 1 minus 3 by 2 minus 1.5, and j 2 and minus j 2 will get cancelled. Then 5 plus 5 by 2 is 5 itself. Then 1 minus j 2 and minus 4 plus j 2, again minus 1.5, and then this one and this one, 2 plus 1 sorry 2 plus j2, so it will be 2 plus j, and j4 it will be j2. So, symmetric component you can see for yourself on the right hand side and left hand side, the imaginary parts are complex conjugates, they are just of opposite signs, alright. This is j2, this is minus j2, this is 2 plus j, this is 2 minus j, this is minus 1.5 minus 1.5. So, this is a symmetric component. Similarly, the anti-symmetric component, you can see for yourself, j2, j1, 2.5 plus j2, then 0, then minus 2.5 plus j2, then j1, j2. In the antisymmetric component you will find the imaginary parts remain as it is, it is a real part which will be having opposite signs. Okay. Yes, please. Is this all right? Now, we have H1n as one system's impulse response, there is another system H2n. This is the input xn, this is the output yn. So, xn the convolution that we performed earlier is represented in a compact form like this. Xn star H1n is the output from this block. Okay. Let us call it as some intermediate output y intermediate n, this one yn convolved with H2n gives me yn. Okay. So, basically xn star H1n, the whole thing again convolved with H2n is equal to yn. Now, we will show that order of appearance of these two blocks will not change the final output. That means, this is xn star H2n star H1n, it will be same as this. You can also sorry, you can also see xn star any hn can be written as hn star xn, because you must have observed when we are discussing about the terms, see it was x0 h0, x0 h1, x1 h0. So, you could have interchanged the positions of h and x, all right. So, h convolved with xn is same as x convolved with hn. Okay. So, we will be showing that if there are two such blocks, you can interchange them, or you can also interchange with input. I could have put a sequence corresponding to H1n as the input, and if a system's response is equivalent to a sequence xn, then also I will get the same output. It is same as this. Okay. Again you can interchange these also. You could have put H2 as the input. So, let us take a very simple example, Hn given as H0, H1, H2. I am taking small sequences for convenience. You can try with any other sequence. Similarly, some yn as y0, y1, y2. I have taken x, h and y instead of h1, h2, because the individual terms are also having h1, h2. To avoid confusion, I have taken 3 sequences xn, hn, yn. I could have chosen anything else and say the output is Zn. Okay. What is the output corresponding to this first two? If you remember, H0, H1, H2, X0, X1, X2. The output sequence that we got was X0, H0, then X0, H1 plus X1, H0, then the next output was X0, H2 plus X1, H1 plus X2, H0. Okay. Next, this one X0, H2, there is nothing like H3. So, X1, H2 plus H2, X1. Last one was H2, X2. Okay. So, these were the 5 outputs. Now, let us feed that. This is the output here. The one that we have got here is output here. All right. Now, this is to be convolved with yn. So, let us take it in the next step. This is my input and this is y0, y1, y2. This is sitting over here. So, what will be the output here? It will be y0, x0, h0. All right. Next, y0 into x0, h1 plus y0, x1, h0. All right. Next, x0, h2, y0 plus x1, h1, y0 plus x2, h0, y0. Agreed? Then x1, h2, y0 plus h2, x1, y0. Next, h2, x2 y0. Okay. Now, the same sequence, let me write with a little distance. Now, this gets multiplied by y1, this sequence gets multiplied by y1 and shifted by one step forward. So, here it will be x0 h0 y1 x0 h1 y1 plus x1 h0 y1, all of them are multiplied just by y1 x0 h2 y1 plus x1 h1 y1 plus x2 h0 y1, and here it will be x1 h2 y1 plus h2 x1 y1. Next it will be h2 x2 y1, and lastly y2, it will start from here, it will be x0 h0 y2 x0 h1 y2 plus x1 h0 y2, then x0 h2 y2 plus x1 h1 y2 plus x2 h0 y1, sorry y2. Next x1 h2 y2 plus h2 x1 y2, and the last term will be h2 x2 y2. Now, what will be the overall response Zn? First one will be h0 x0 y0, all right. Next you add up these, there is shortage of space, but anyway if you add up column wise you can see the terms. The first one will be all zeros, then x0 y0 h1, the sum is 1 and all possible combinations of x, h and y. The sum is 2 starting from 0 to 2 of all these indices, all possible combinations that you can think of. Okay. x0 h2 y0, keeping y0 fixed, you vary the other two, get a combination of total sum of 2, then again vary y to y1 and then get the combination as 1, so that the total sum is 2 and so on. Similarly, the next column. So, you find I can from these general terms, since all possible terms are present, you can always have any combinations of appearing of appearance of hn and yn, or for that matter xn. Is that all right? So, output of such sequences which are interchangeable will remain intact. This is all for a linear system. If you have h1n, h2n, yn, in this case is h2n convolved with xn plus h1n convolved with xn. This is y1 and y2. If I write this as, this is y1, this is y2, then this is xn star H1 plus Xn star H2. So, that is same as Xn star. If you take term by term, you will find the sequences H1 and H2 are basically added and convolved with X star n. You can try with one example again, very similar to this kind of table you can make. So, this can be written as H1n plus H2n. Okay. So, basically we write Xn, sometimes people write T for transformation, not for delay, capital T for transformation, that is Xn gets transformed to Yn through this system function. So, T is nothing but this sequence. Hn is one representation, T is the system, all right. We call it in general a filter. Anything, any system is a filter. Need not be one of those standard ones, but anything, any system is trying to alter the input and give you a corresponding output Yn. So, sometimes called a general transform of the system or a filter. Sinusoidal sequence, well, today the time is over, we will take it up in the next class. Thank you very much.